Children, you might be following different books. What you can say for study. In certain books, as I said you, that it will be given the electrochemical series in the increasing order of reduction potential, from negative to positive. In certain books, it will be given from positive to negative also. It will be given in the decreasing order of reduction potential. Alright. In some books, it is also given in oxidation potential. Also, it is being given. Alright. So see accordingly and then study. See accordingly. Don't get confused. Alright. See the heading accordingly. How it is being given. Whether it is given in the increasing order of reduction potential, whether it is given in the decreasing order of reduction potential, whether it is given in oxidation potential. Alright, so hence make your concept clear accordingly. So just stick to one particular thing. So what I am saying you just stick to this particular thing, because this is your, according to the international system I am saying it, that the series is being made in the increasing order of reduction potential. Alright, clear now? For that purpose I said you this thing. Now the next application of the electrochemical series is that from the electrochemical series we can come to know about the reactivity of the metals. About the reactivity. You will say we have studied in lower classes that potassium is more reactive than sodium is more reactive than what you can say calcium, aluminium, we have studied. Okay, fine. When the name is given you know that. But if it is given in this way, A, B, C, D in this way is given. Name is not given. Rather, the electrode potential is given to you. Suppose the electrode potential of this is minus 3.05 volt, let us say. This one is how much? 2.15 volt, let us say. This one is 1.3 volt, let us say. This one is minus 0.79 volt, let us say. Okay, so in this way, the different electrode potential is given. Name is not there. Then what do you do? If the name is there, then it's okay. You know it, you will be arranging it. The one which is more reactive and the one which is less reactive. In this way it is given, X, Y, Z or A, B, C, D is being given. How will you know it then? You will be arranging it in the increasing order of the reduction potential. Alright? That means, now listen carefully. The one which is having the higher reduction potential, alright, higher reduction potential. So, here the higher reduction potential is this. It is the least reactive. Because the electrochemical series, it is being, what I have taken the electrochemical series from negative to positive. So in the negative value, which is the maximum, that is the most reactive. And the positive value, which is the minimum, which is the what you can say maximum, that is the least reactive. Alright, I am sorry, in the positive value, which is the maximum, is the least reactive. Because what I am saying, I am arranging it in increasing order from negative to positive, I am arranging it. So here, what I said you here is that in negative, which is the maximum? A is the maximum. So A is the most reactive. After that, what do we get it? In the negative? See, the electrochemical series is not negative to positive. It is being arranged in the increasing order of the reduction potential. The same order is your reactivity. The same order is your reactivity. That is from negative to positive. The same order. Why it is? I am going to tell you the reason. First, let me tell you this answer. So it is A. Then after that, which it is nothing but is your D. Then after that, which is there, it is nothing but is your C, and after that, what is that? B. So this is your increasing order of the reactivity. So A is more reactive than D, D is more reactive than C, C is more reactive than B. That is from the reduction potential we came to know. Alright, from negative to positive. Now the question is, why did I arrange in this way? Why did I arrange in this way? What I said you, with one which is there at the top of the series. It is having the, what you can say, the strongest reducing agent. I told you. The reducing agent, what it does? It reduces other substances, but itself it gets oxidized. Oxidized means itself it loses electrons. So, listen carefully now. The element which loses electrons readily, that means the one which gets oxidized easily, is the most reactive in nature. Note it and write it down. The electrode or the element or the metal or whatever it is, which loses electrons readily, gets most easily oxidized. Because what I said you, at the top of the series, again I repeat, what is there? Reducing agent, strong reducing agent, Li+. Reducing agent, what it does? It reduces other substances, but itself it gets oxidized. Oxidizing means what? Itself it loses electrons. Same thing. So the one which loses electrons readily, the one which gets oxidized easily, that is the most reactive, what you can say, substance. That is the most reactive electrode. That is the most reactive metal. If you are seeing all are metals, then the most reactive metal. Got it? So in this way, the one which is having the what you can say, the higher reduction potential, higher means the positive value. So that means it is not losing electrons readily, it gains electrons readily. Alright, it does not lose electrons readily, because what I said you at the bottom series, what you are having, oxidizing agent. Oxidizing agent oxidizes other substances, but itself it gets reduced, we can say that. Clear? So in this way, what we find is, here you can see is there, that A is more reactive than D is more reactive than C is more reactive than B. So in this way, A, B, C, D or X, Y, Z, if it is given to you and electrode potential is given to you, what you do is that from negative to positive, you just arrange it. That's it. So in this way, you will be getting the reactivity of the metals you will be getting. That's the next application. Now, the another application of the electrochemical series is, that is, suppose we are having a metal, alright, whether it will displace another metal or not, how do we come to know? Alright, suppose this reaction Zn plus CuSO4 gives ZnSO4 plus Cu. So here what is happening? Zinc is displacing copper and it comes in the place of copper. Simple. It's a displacement reaction. So whether this reaction is possible or not, how do we come to know? So if this is having, what you can say, listen carefully, if the electrode potential of this is, what you can say, it is lower, means it is negative, more negative than this, then it is going to displace, because this is going to get easily oxidized. So in the electrochemical series, you will find zinc is placed above hydrogen and copper is placed below hydrogen. So what you find is that zinc is more reactive than copper, because just now I said you that elements are arranged, the electrode are arranged in the increasing order of reduction potential. In same order, the reactivity is also being arranged in the same order. That means elements which are placed at the top of the series are more reactive than elements which are placed at the bottom of the series. So what I said you, copper is placed at the bottom, almost at the bottom, below hydrogen, the copper is placed, because the reduction potential is positive. I remember it, so I am saying it. No need to remember, in the exam it will be given to you. So in this way, what you find is that this element is having higher reduction potential than that of zinc. So zinc is having a tendency to lose electrons easily, to get oxidized easily, so hence it will displace this particular element. So what you need to see here, what you need to see, what is the shortcut, what you need to understand here. Suppose the electrode potential is given here, it will be given to you, no doubt about it. You have to see whose electrode potential is in negative, it is more. Suppose both are negative. Let us say, sir, both are negative is there. Then what will I do? The one which negative value is more. Suppose one negative value is minus 3.9 volt, let us say. And another negative value is minus 2.3 volt. Definitely this is more. So this is going to displace this element. Finished. Because this is more reactive than this. Over. In this way. So what you need to see is always electrode potential you need to see. Alright. So this element is having, that is more what you can say, oxidation potential. If you talk to me, because it is having negative oxidation potential, so it is more oxidized easily, it gets easily oxidized than this. Alright, than this. Or in terms of electrode potential, the one which is having the lower reduction potential can displace the element which is having the higher reduction potential. The one which is having the lower reduction potential, means negative value, can displace the element which is having positive value. Or if both the values are negative, or if both the values are positive, suppose if both the values are positive, if both the values are positive, then who will displace whom? Then this will displace this. This is going to displace this particular one is going to displace this to 3.9. Suppose this is X and this is Y, then X will displace Y if both are positive. But if suppose here both are negative, then what will happen? Y is going to displace X. Alright, suppose if this is negative, this is positive, so definitely this is anode and this is cathode. So hence this is going to displace, what you can say, X. So Y is going to displace X. I hope it is clear, this particular thing. Now next, after that, suppose I am writing a particular reaction. So in that reaction, whether hydrogen gas will be evolved or not, how do we come to know? Now you have read in the lower classes, the metals which are placed above hydrogen in the electrochemical series will displace hydrogen. That means, in short, I should say, the electrodes having negative value of reduction potential will displace hydrogen from its acids. Electrodes having negative value of reduction potential will displace hydrogen from its acids. Negative value. So which elements are there? You can see it in the electrochemical series. Zinc is there, sodium is there, potassium is there, magnesium is there, aluminum is there, calcium is there, strontium is there. So these elements, they are going to displace hydrogen from its acids. So when zinc will react with HCl, will give you ZnCl2 plus H2, because zinc is having negative electrode potential and hydrogen is 0. Suppose here if I take copper, no, because copper electrode potential is positive. If I take silver, no. If I take mercury, no. If I take gold, no. It is not. Why? Because the electrode potential is higher than that of hydrogen. So what I should say, here the electrode potential of particular, that is electrode, if it is less than that of hydrogen, that means it is negative. It is going to displace hydrogen from its acids. Are you noting this point? Note down this point very clearly. Alright, clear. The elements which is having, or the electrode which is having lower reduction potential will displace the hydrogen from its acids. Okay, fine. Thank you.